Oh, hi.
Hey.
Good to see you.
I'm
Not seeing him, silly. All right, so this is a theorem that you are going to work with the derivative of the inverse function. Okay, that's very specific. Okay, and the whole point is that we aren't going to have to do the inverse to find the derivative of the inverse. Okay, so hopefully that'll be understandable. But there's a function that we're using. This is our if f is differentiable at every point on the interval, and df dx is never 0 on the interval, then f has an inverse, and f inverse is differentiable at every point. Okay, so f inverse derivative, which is what we did right here, f inverse derivative at 2. Okay, so let's say we're going to use this formula with the function that we used up here, which was, what was it? Radical x plus 3. Okay. All right. So we're going to use this formula. Now, I did not this did not come out of thin air. I'll show you where it came from in a minute, but let's just work with it. And you might be able to show me where it came from. Okay. So we're going to find f inverse of 2, the derivative of that. Okay, that's what we're going to find. And it should be 4. Okay, it's not really trouble. All right, so here's what we're going to do. Without finding f inverse. Okay, we're going to use this formula instead. Okay, f inverse derivative at 2 equals 1 over f derivative of f inverse of x. Okay? Now, x is, remember, 2. Okay? Now, how can we find the inverse without finding the equation? How can we find the thing? Here's what I do. This is my organization. This is f of x and f of x. And then this is f x and f inverse of x. Okay, it's like a little chart. Okay, just my organizational angle piece. Okay, so we want to know what the inverse f of 2 is. So we want to know when x is 2, what's the inverse function at 2. Now we don't know, we're not supposed to know what the f inverse of 2 is. Okay, but what do you know about inverse? If at this function, which is the inverse function, what happens over here? 2 equals f of x. Who said that? Ito? Awesome. Okay? That's what happens on your inverse functions. You switch these guys around. So what we want to know is when is 2 equal to f of x? You think you can solve that? Of course you can. This is f of x. We want to know when it equals 2. So what are we going to do first? Square it. Okay, and we got x equals 7, right? So this is 7. That makes that 7. Where all that garbage comes from? Probably from my hand. Okay, so what are we going to put for 1 of f prime of f inverse of 2 is 7, right? Okay, now how am I going to find the f derivative of f at 7? Well, I know what f of x is, right? It's this. What's f prime? 1/2 u to the 1/2, where u is x minus 3, right? So 1/2 u to the negative 1/2 times, what's the derivative of x minus 3? 1. Okay. 1/2 u is derivative x minus 3. Okay. Plug in your 4. 7. I know I probably lost some of you. Don't worry about it because we're going to do plenty more that you. So what's this? Radical 7 minus 3. Radical 7 minus 3 is radical 4. What's radical 4? 2, and there's my 1/4. I'm supposed to get 4. What happened? It's 1 over, duh. Just saw that, right? Did you say that, Mary Grace? Okay. 1 over 1/4, which equals 4. Okay?
I think you guys have done like a trial.
Do what?
I do every single time. I like not at all, but like when you have 1 over a fraction, that's what I like. But every time I was like, where do we get the 1 over?
We did.
Where do we get that 1?
This was the 1 over, okay. Kind of. All right, this was this, right? Which was this. You was this. And then we said, let me do this. Okay.
That's the 1.
All right, and now remember we got to take it back up here. So F inverse at 2 was 1 over 1/4, which gives us the 4 that we knew we were supposed to end up. Okay? I know that's like, oh my God, I just blew my brain here. Okay, so let's go back. That sounds really bad, doesn't it? Yeah, just go grab the thing. Just grab the box of money and then we'll wait. Oh. Okay. Okay. All right. So this is kind of where we should have started. As far as this is kind of getting you ready to just remember what inverses are. So here we go. All right. We got F and its inverse, F and inverse. B differential functions, okay, we have to kind of assume that with f of x values at x equals 1, 2, 3, and here's your f of x, here's your f prime of x at 1, 2, 3. Okay, so just to remember, if you're dealing with 1, 3, in your inverse, that's the same as 3, 1, right? I mean, it's not the same. It gives you 3, 1. So if you have a point 1, 2, which is 2, 1 rather, what's the inverse point? 1, 2. Okay? If you have a point 3, 2, on the inverse, it's 2, 3. Now the derivatives are there, just don't have anything to do with inverse yet, but we're going to put them in there. Okay. So here it says find the derivative of the inverse at x equals 1 and x equals 2. Okay, we're going to use the formula because clearly we don't know what f is. So therefore, we can't find f inverse. So therefore, we can't do like we did with that radical x minus 3. Okay, so we're going to use the formula. So let's go back here. It's right here. So f, do what? It's the same. It should be the same one. Yeah. F. Hold on. Let me get. Yes, okay. Is that the one I want? Yes, this one right here. Okay, this is the formula. So F inverse, the derivative of the inverse, okay, equals 1 over F derivative at the inverse of X, okay? Now, you'll remember that, or you won't, and I'll show you how, if you don't remember that, how you will derive that. We'll go back to that page. Okay, so this is the formula that you're going to use. Let me go back to the same page. All right. So we're going to do it x equals 1. All right, so F inverse derivative of the inverse at 1. This is this one. Okay? All right, equals 1 over F derivative at F inverse of 1. Okay, so Again, I like my little chart. If x is 1, f of x is what? On this particular problem, if x is 1, f of x is 3. Okay? That makes, if x is on the inverse, remember we talked about that, but again, we switch them around, right? Okay. So, what does that tell us? This means on the inverse function right here, x is 1. Hold on. That's supposed to be the inverse function. Where's my inverse function? Did I do those backwards? Oh, that says, what's going on here?
Are those really the derivatives and then just written as primes instead of?
No, I don't. These are the order pairs, 1, 3, 2, 1, and 3, 2. All right. Okay. We're back. All right. So let's see. Oh, big eraser. Okay. All right. X, f of x. All right. X, f inverse. Okay. We need to know when the inverse is 1. So the x is 1 on the inverse. Okay. So that makes 1 on, if x is the 1 on the inverse, it's the y on the regular function, right? Because that's what inverse does. So which one ends in 1? Here. It's going to be this one, right? All right, so this is 2. All right, so this piece right here is f prime at 2. Okay? Now, the f prime at 2, we know f of x is, we don't know how to function, but do we know the f prime at 2? Look. Right there is f prime at 2. So this is 1 over 5. Done. We don't have a function that we're going to plug it in, so it's supposed to be easier. Okay. Let's do another one. All right. Got so much going on this page. All right, let me start another page.
Are we usually going to be given this primes too?
No, it just depends. Okay, you want at 2 this time?
Yes.
Okay. All right, tell me the function. What is that equal to? 1 over what? F prime, F inverse at 2. All right. Okay. Now, if F this says I want to know what the inverse is when x is 2 of the inverse. Okay? So that means if it's x over here, it's y over here on the regular function, right? The inverse gets them switched. Okay, go back and check. Where is the function for that table? Where is f of x 2? Where x equals 3. So very good. So we put a 3 here, and this is 3. Does that make sense?
Yes.
Okay. We're going to be very deliberate about everything here. Okay, now, f prime of 3 comes off the chart. What is the f prime of 3? You go on the chart, f prime of 3 is 6. We're done. That's 1 6. Okay, those are table values. Okay. All right, let's try one where we actually get an equation instead of the table value. Are you ready? Does anybody have a question over this? All right. I think there's one on that page right here. Okay. So again, I'm going to give me another page because it's going to take a while here. Just move it all over here. Okay. Did it move?
You ran into the recording.
Okay. All right.
Whoa. You just hit exit.
All right. Thanks. Okay, here we go. Okay. F is an equation and H is the inverse. Okay, so now you got to be careful with the formula. You've got to use F and H instead of F inverse. Okay, so let's recreate the formula. This is what it looks like. Equals 1 over F prime F inverse of X. Right? All right, so H and F are inverses. That's what they said instead of F and F inverse. Okay? So this is going to be H, right? H prime at 2, that's what it says I want, equals F prime of H of X. That make sense? Okay. All right, so I'm going to rewrite that because I can't read it. So H prime at 2 equals 1 over F prime H of X. All right, we have X and F of X, and then we have X and H of X, which is, this is the inverse. All right, H of X really wants to be 2, right? That was supposed to be 2. Okay. The H of 2. That 2 is in the X spot. All right, we want to know over here, the 2 belongs, if it's X over here, it's F of X here. So here we want to know F of X is really what? 2, but it's also X cubed plus X. Okay, did I lose anybody? All right, now get your calculator out. Do what you got to do to find what X is. You can probably see what it is, can you? It's going to be 1, right? Because 1 cubed plus 1 is 1. That's just an easy one to do. But if you didn't see that, you would put this in y1, put this in y2, and then do an intersection. That would be probably the easiest way to do it. Okay? We'll do that later for the next one. All right. So that makes this one right here and this one right here, right? Okay. So that makes H of 2 what? 1. So this is 1. We just found that out. All right, so really we have 1 over F prime of 1. Okay, so good. All right, what was F of X again? F of X is X cubed plus X. So F prime of X would be what? X squared plus 1 at 1 would be what? So then you put the 4 here and your 1, and there's your answer. Okay?
On the test, because that's a huge process.
It is. So there's your answer right there. Okay? There's probably only one, but it may evolve into something else. Okay. All right, let's go back and make sure you know, because you may forget it. You might have my memory. That's supposed to be inverse. You can hardly see it. I want you to know where this thing came from, and then we'll grab some more. Okay. So where this comes from is pre-cal, of course, the root of all evil. What does this equal? If F and F minus 1 are inverses of each other, which they are, it equals X, right? Very good. Okay. So that's a known fact, just like, you know, if we go the other direction, it's the same idea. Okay, so what we're going to do is we're going to differentiate. We're going to take the derivative of that side and the derivative of that side. Okay? There we go. I know. Okay. We're differentiating. You should recognize this as a chain rule application. Composite function. So when we change, we take this times the that of that. And then what's the inside piece? Times what? Derivative equals, what's the derivative of that? 1. This right here is the chain rule. There it is. If you look under the chain rule derivatives, it's f and g, same idea. So you have f prime of the inverse function times the derivative of the inverse function. Okay, now, we want the derivative of the inverse function, so if we want this to be by itself, what are we going to do with this mess? Divide it. F prime f inverse of x, f prime f inverse of x. So there you have your answer right here. F inverse derivative of x equals, it's kind of messed up, so let me redo it. Equals 1 over f prime f inverse of x. That's the one we've been working with.
So did this just like somebody ran into a roadblock and to do the derivative?
Apparently. Yeah, because the problem is, like, just think about that last problem. Would you want to really do, okay, this was the function. This is the inverse. You really want to solve that for y? You can't, really, implicitly. That's why we have the implicit differentiation, and that's why we have this. Okay, so let's try another one. Did you get this? So if you were doing f and h, then you would probably start with this. F of the h of x equals x. Okay, and you differentiate both sides. And then you'd say f prime h of x times h prime of x. That's a chain rule f. And there we go. You want h prime of x. So it's 1 over this mess. And you know my memory is really bad.
Or h of x.
Okay? That'd be like that.
Do you remember that your memory's bad?
My memory is bad. I don't have any problem remembering that detail. So I will start here pretty much. If I recognize that, oh, I got to do that, I'll just start there. Because this, to me, makes me crazy starting from that point. So I will start here. Okay?
Substitute. Like,
Yes, if you memorize it, yeah, you'll just substitute that, like we did in that problem. We substitute the inverse for h, or, but they're going to switch up the names all the time.
I just think if we get to work and there's a problem, I don't h of x, we would assume that h is definitely.
Not to assume, they will tell you that, yes. Okay, let's find a new problem right here. Okay. Let's see, f of x, all right. Okay. And the good news is the homework is all the same kind of deal, all right? So you're going to get like 10 problems, and you'll be like, okay, I know where to start with them all, but now you got to recognize them. That's the bad news when you get mixed up with everything else. Okay. Let the calculator determine the derivative of the inverse function of x at x equals 4. It sounds like, oh, let's just plug it in. It's not quite that easy. Okay. Derivative of the inverse. All right, so here's what you're thinking. F inverse derivative at, where are we? 4 equals 1 over f prime f inverse at 4. Okay? If it bothers you to put the 4 in, then put it in later, it's okay. Sometimes if you've got a memorized formula, you want to use the x and then put the 4 in later, that's okay. All right, so again, we want to know, here's x and f of x. We know what x and f inverse. We know we want this to be 4. Okay, so what are we going to solve? So f of x equals 4, so 4 equals x to the 5th plus x to the 3rd plus 2x minus 2. All right, so we get put that in our calculator. Y1, I'll put in x to the 5th plus x to the 3rd plus 2x minus 2, and then I'll put in a 4 for y2. Okay? And then, what do I want to do when I graph them? I want to look for what? Intersection. Very good. Okay. I don't know what my... Yes, I can see everything I'm doing on this screen. All right, so 4 is going to go straight across. All right. All right, remember how to find the intersection. If there's only one, you can hit enter 3 times, and it's going to give you the intersection. Okay. There's your intersection. All right. Here it is. Okay, so what's this? 1.16124. 1.16124. I would use as many as you have. Okay? So that makes this 1.1612414. Okay? So far, 1 over f prime of 1.161214. Okay? All right, f prime is this. Now, yes, we could find the derivative very easy, but to plug that in, let's just let our calculator do it again. We got a calculator, let's make sure we use it. All right, go back to the home screen and do math 8 for derivative with respect to x. And I'm going to put in that y1. Let's see, it's x. Actually, I have it in y1, so I'm just going to grab that instead of plugging it all in, right? y1 with respect x equals 1 point. Pull it up here. 161214. There you go. There's your derivative. Okay. So we have 1 over 15.31374, blah, blah, blah. Okay. How do I flip that around? Okay. 1 over answer. Okay. So your answer is 0.06. Now we can go to 3 decimals. What was it? 0.66. Okay. So it wasn't so bad that you got to let your calculator use it to do that. It wasn't that bad. Come on. Okay. All right. Yes. Okay. Some of them. All right. Let f and g and their inverses. F and g inverse be differentiable functions. They have to tell you that because otherwise you don't know. And let the values of f, g, and the derivatives f prime, g prime at x equals 1 and x equals 2 be given at the table. Okay? Determine the value of each of the following. All right, let's do A. It says I want the derivative of f plus g at x equals 2. Okay, this is not new information. F plus g derivative at 2. Okay, so what am I going to do? I'm going to do f prime of 2 plus the g prime of 2, aren't I? Okay, so it's a piece of cake, right? What's the f prime of 2? 6. And what's the g prime of 2? 7. And 6 plus 7 is 13. I'm done with A. Okay? All right? So
it's just mixed problems.
Yeah, this just makes problems. Yeah, this is like a free response. What's the matter?
6
All right, let's go down to C, because we're not going to have time to do all A, B, C, D, and E. C says the derivative of F over G. Okay, so F over G derivative at 2. Now again, if this notation is messing you up, then you go back and you say, okay, do this. So what rule are we going to use here? Quotient. F of X, G of X minus F of X, G prime of X over what? Okay. And then you can put your, if you like now, you can put your, what are we doing? 2 in. So I'm a 2 here, 2 here, 2 here, 2 here, 2 here. We've done this before. 2, 2, 2, 2, 2. And some of you that wouldn't bother to do right away, so you could just talk. We did one kind of like this on the last test, right? And then you fill in the numbers. F prime of 2 is what? 6. G of 2 is minus F of 2. G prime of 2 over G of 2, which was pi squared. So what? 6 pi minus 14 over pi squared. Done. Okay? Now, you ready for a derivative of an inverse? Yes. Okay, which one would that be? Both D and E. I think. Yeah. Let's do E. It's clearly an inverse. We have to think about D. Okay. Derivative of G inverse at X equals 2. Okay. Derivative of G inverse at 2. 1 over G prime. I heard it. I'm just going to finish. So you all need to go. G prime, what's the rest of it? G inverse of 2. Okay, that's your formula that you're supposed to know, or that you can figure out if you don't. Okay. X, G of X, I got to do an inverse. My inverses are not given to me, so I can figure them out. Okay, this is 2. On the G side here, where is it 2? Right, so X is 1. This is 2, 1. So this is G prime of 1, right? What's the G prime of 1? Yes, it is. So this is 1/4. I'm done. Yes, I do.